Hi there, if you're just joining us, this is the second video in how to apply heat pump water heaters in EnergyPlus in a simplified configuration. My name is Neil Bolger of A2 Efficiency, and this is a helpful guide for anyone who's looking to evaluate heat pump water heaters in the software. The first video kind of goes over the background, what a heat pump water heater is. In this video, we're going to go over how you would go from having a basic energy modeling configuration, some ideas of this. I'm calling it like the system architecture. So you have a sense of like, what's the heat pump water heater going to look like? Should it have a backup heat? Should it have a tank? Um, what are some sizes we want? And then you're going to try and put that into EnergyPlus, make some assumptions to evaluate energy use, maybe compared to other types of heaters. So in this video, we're going to go over the plumbing um, in EnergyPlus. Last video, we kind of went over the plumbing of these systems here conceptually. Check out that video if you want to learn more. All right, so in EnergyPlus, there are four objects. I guess there's actually the fifth object would be the pump on the branch of all of these things, but we're not really going to talk about that. It's kind of used with the other water heaters as well. But what we're going to look at is these four components. So there's this basic, the main component is called the water heater heat pump pumped condenser. So it has and it basically means it has it's pumping the condenser water, the water to a tank. Here's our stratified water heater tank. It has a separate object that is the actual compressor. They call it the heat pump pumped, the air to water, it's a coil. Water heating, air to water heat pump pumped. Essentially though, this is the compressor. This is where we'll put in the details of like how big is it, what's the efficiency, and then separately it strips out the fan that is exchanging the heat, the evaporator fan that's pulling the heat from outside, or a room in this case, if it's in a room. And we're going to look at this configuration in EnergyPlus. And then I'll make another video after this on how you could put this in a room and use these nodes, air inlet, air outlet. But right now, we're basically assuming this is an outside system. So I've drawn it down here. There's an input for this device called the outdoor air node. The air goes into the evaporator. It goes out of that evaporator and then like into the fan, across the fan essentially. Oop. Into the exhaust node and then into the whole system. There's then a connection between the tank and the water heater, the source side and the condenser, right? So if this is the compressor over here making the heat, the condenser water is pushing it into the tank and then back out. And that's kind of our lovely little configuration. So we're going to flip over to EnergyPlus. I guess as I go there, what are we starting with? So we are starting with briefly here in SketchUp. So what I did is I went and I grabbed the medium office for ASHRAE 90.1 2022, which looks like this, fun square box. But there's a bunch of zones, and each zone, so each floor has 4 zones. There's 5 zones. 5 times 3, there's 15 zones. Each one has a water flow rate and schedule. They all use the same schedule, and they all have the same flow rate actually for hot water. But we're going to use all of those and size our system. So right here, this is the model that I took apart. So previously it had a water heater mixed that was just a natural gas water heater. Here it is. And so we took this out, and I'm going to now flip over to this one. I believe this is the right one. Let's check real quick. Yes. Okay, so in this one, we've put our components in. So we have let's go down there in different spots. This is the main object I talked about, the pumped condenser object. I'm kind of calling it the main object because it's where it stitches the other objects together. It asks like, what is the name of the tank? What type of tank is it? It's a water heater stratified tank. Okay, great. And then down here it says, well, what kind of object are you using to make heat? It says, oh, I'm using this type of object, and it has a name. You could pick, apparently you can pick some other objects. There's a variable speed one. I'm sure that was probably interesting to look at. There's another one here, integrated heat pump air source, but this is the one we're going to use today. And also the name of the fan, right? So I think of it as the parent object because it pulls the other ones together. There's some inputs here that are also important. Like this is where we'll come back to on, it pulls heat from the outside. You could also change it to be a zone or a schedule, apparently, or both. I think this is not used air inlet zone node. So if we were pulling from a zone, this would matter more and our air inlet and outlet would matter. But right now we're pulling heat from outside and rejecting outside. So that's that object. And then we're going to quickly look at these other ones. This is the compressor. So it has a size, it has the COP, the efficiency. It has a whole bunch of information on the temperature that it is rated at for efficiency. And we'll talk a bit about this. This would be the temperature of the compressor's rating. So either 17 or 47, depending on what you're using for ratings. And then other information on when it runs and operates. What else is critical down here? It has the crankcase heater. It has a condenser water pump. We'll touch on those in the spreadsheet. And then up further is our little fan system model. So here's the fan and the evaporator. Very basic inputs, just takes a pressure drop and an efficiency that it's operating at. I just assumed 1/2 inch of pressure drop and 50% efficiency. Those are it, right? Those are the things that make up our tank. Oh, and the stratified tank. How could I forget the tank? So in the tank, this is where the gallons, the size of the tank goes in. You have to enter all the dimensions. So how tall is it? How wide is it? And then information on where the first heating device is located, heater 1. The second heating device, that's usually located a bit further down, is located. For both of these, you have to put in the electric power that it consumes. So in my configuration, we're going to assume the first one has no power and that we're only heating the bottom of the tank with a backup device. It's a little bit more of an efficient configuration. And then a bunch of information on the thermal losses, parasitic losses. If it's located in a zone, what zone is it in? And then it's heat losses that go into that zone. Kind of going down, there's a whole bunch more inputs you could specify, but we'll get to some of these key ones. So those are the components. Okay, let's flip over to Excel. So what do we have? All right, so this is our tool. And what we're going to do is walk through this tool and then go back and forth to EnergyPlus. So in this tool, I've tried to color things from inputs you're going to need to specify in orange, and then inputs in blue that you put into EnergyPlus. I then also started to realize a lot of these orange ones also go in. So we made another column that says, are these EnergyPlus inputs? Yes, yes, yes. And you'll see some of these I've written down in Fahrenheit, some in Celsius, which I realize is a little annoying. So you'll have to flip back and forth in the software as you type them in. Or you can type in like Fahrenheit, for instance, here, if you want to type F in instead of Celsius. All right, so right now, maybe we'll even start at the bottom. Let's start at the bottom. So what I did is in the model, I went and I found that every zone has a flow rate of water. And here I just directly typed it in from EnergyPlus. It's in meters cubed per second. There's 15 zones, they all have the same flow. So I know that the flow of water is this many gallons per minute. I'm actually just converting here to gallons per minute. They're then all using this fractional schedule where I just put it in here for 1 day because I use the same day every day. You can see it here. And I'm just adding it up. So this many minutes. And so if we know this many minutes times this flow rate, we could figure out how much hot water do they need in a day. And that kind of takes us to the top, the daily hot water draw. They need this many gallons, 258.6 gallons. I then, for sizing, you'll see this in a bit, I said, well, what's just 1 hour of flow? If we're at max flow for 60 minutes, how much water is that? So we're going to use that, 51 gallons. And then we get into these sizing temperatures. So this is all related to the efficiency, right? If you change the water temperature, but you're going to be somewhere between like 120 and 130, somewhere in there. The system has to push water. So even if water's going down the drain, you do need to have a delta T. So I'm going to assume a 9 degree delta T. You can then specify, and we're going to need it when we do sizing, a peak water temperature from the street. EnergyPlus actually has this as an input. What is the cold water? Changes each month. You're going to need a number. So if it's cold where you live and it's not 60 and it's 45, type that in. I'm going to pick 60 for now. It's going to be used when we size the compressor and everything else. We then have to do a recovery time, so a window to fully recharge the tank. We then have to put an efficiency, or I like to have, you don't have to do this, but I made an input for how stratified is the tank and how does that impact efficiency. Basically just like another way of like oversizing the system. So we're going to assume it's 80% stratified, not perfect. What's the efficiency? This is the most critical one, right? So this is probably the biggest input. So if we have a product that you might evaluate a few products, but really work towards knowing like what is your compressor rated at. So here I'm going to say 3. So down here, now let's get into, we're going to use these sort of basic inputs. I didn't even put a category here. I guess we'll call them basic inputs to start to go through the components. And, you know, apologize, these fields are not in any specific order. I arranged them a little bit before I made this to try and group them, but it's not like this is the object in EnergyPlus. These are the hand calcs you have to do and arranged in a logical format so you can kind of work top down. So for this one, we're really working towards like, how big is the compressor? What are we going to do with this thing? So to start off, we need to think about, well, how big should it be? So we're going to start by saying, well, the daily energy use, if we just had made all the energy in the day, it would be this big, this many BTUs. And then we could say, well, I really don't want to size it for the whole day. That doesn't make sense. Let's just size, in this instance, I'm going to size it based on 2.5 hours of the peak. So I'm just taking, I'm taking the peak load and I'm basically taking a ratio of the gallons to the peak load, saying take 51 times 2.5 divided by the total gallons I would need in this energy use. So I really need to make this much energy in a day to size my tank. Oh yeah, this is to size the tank. And then from there we can use the delta T in the water and from the street. So this is a different delta T. It's like cold water in, hot water out, stratification. And from that it'll say, okay, you need 159 gallons. Great. Now we have our gallons to put in. And this actually is an EnergyPlus input, which actually is down here in this object. But let's just put a little yes while we're here. We're just making improvements all the time. Okay, now we know the tank. And from there, we then need to say, well, how big should the heat pump be, right? So if we were in this one, we're saying, well, if we have to make this much energy in a day and we want to recover it in 6 hours, that means I need to be running this thing at this rate of heat generation, 24,000 BTUs. And depending on how you're specifying things in SI or IP, that's 7,000 watts. So that's a key input. The compressor is 7,000 watts of heat capacity. And then there's some checks I was doing, gallons per kilowatt. I used to have some ratios over here, but trying to see, is that reasonable? I'm making this up, trying to be a rational system. I want to do some self-checking against other products. But moving on, so tied to really the efficiency, in the software, you have to say, what was the efficiency rated at? So there was some evaporator temperature for inlet and outlet, inlet dry bulb and wet bulb. Over here, I've sort of given you, if it's 47 dry bulb, use 43 wet bulb. If it's 17 dry bulb, use 15 wet bulb. Those two are the common test procedure published efficiency values you'll find. 17 in cold climates, 47 in mild climates. So other inputs you have to put in, the rated condenser inlet water. So here we're just taking the leaving water minus, essentially this is like if it was recirculating for some reason, because this system could be configured later in that way, but you have to type this in. So you just take this leaving water temperature minus your delta T. These are the two input fields you can actually auto calculate, which is an input in EnergyPlus. I've seen auto size, now I've seen auto calculate, an interesting input. And then I probably All right, so with that, I'm going to pause here and join us back in another video, and we'll flip over and look at these inputs in Energy Plus.